In terms of the nitrogen cycle, Precision Ag plays a part in making sure we put the right products at the right rate, at the right place, at the right time onto the field. So we do that in a way that gives the plant just what it needs, but it doesn't create excess nitrogen in the environment. We want to make sure then that once that nitrogen is put out, that we can extract as much value as possible from the crop and to limit that impact on the land on which that crop was made. We sense what the crop needs using different types of imagery and UAV systems, or we can also use existing sources of data, whether that's previous yields, soils maps, GPS data that describes what was done previously in that field. So whenever all that comes together, what we hope to do is to put just the right amount of nitrogen to the crop so that it grows fully and we get as much fiscal sustainability and environmental sustainability as possible. So BAE is equipped to deal with this particular grand challenge because we do stand at the face between, in my case, engineering and agriculture, production agriculture. So there's a lot of open questions about how do we optimize this system, but a lot of those are based on the engineered machines, the technology, the sensors, all these things that come together under this idea of precision agriculture or digital agriculture. And that's really driven by work that happens here in the BAE department and the way that we can ground truth it in real world here in the field. So what we're doing here today in the field is that we're flying our drone with different payloads where we try to sense damage that has occurred to that crop. So if we've invested nitrogen into growing this plant, we want to make sure that the grower can harvest it and that it has value to them. So once the investment is made, we need to see the return. In North Carolina, harvest season tends to line up with some severe weather that can be caused by hurricanes. One of the things we're trying to do is to assess if we can find that damage in the field and rate its severity. And the goal there being to create reports very quickly that allow that producer to decide if they want to harvest or make an insurance claim or whatever kind of their down the road decision is, or maybe they need to report that to a disaster response agency. So what we're trying to do is to create a data set that will allow us to train some machine learning models that will automatically identify what has happened in this field in terms of damage. Now that could be weather, that could be wildlife damage, that could be any number of things that would cause the crop itself to damage and to not create value for the grower for the inputs that were put in on it.